from the exam.
That's all on the test yet.
Needs a little bit of
Chicken things also.
Okay, let's make sure. Let's make sure. I don't want to talk. I don't want to talk too loud now because I don't want to, you know, freak out the poultry. But isn't that guy awesome? Hey, dude. Hey, dude.
I like his scrap sack.
Is it nice? That's awesome. I've had sent over. He told me about this in the last quarter, and for all the spring break, I had the phrase "chicken in a diaper" in my no, that was Christmas. No, it's spring break.
It's an experiment. We're about to. It's winter time.
Yeah, so it's winter term. So
See the thermal conductivity of a chicken.
trust me, you are the cock of the walk. You don't have to worry about anybody. They need to worry about you, dude. And his spurs are freshly sharpened, so I'm just going to let you know that ahead of time. So, nonetheless, I need you guys to sort of get going, so go ahead and pick. If you get on early enough, you can do Einstein's Relativity 1 and Relativity 2. But I'm going to have to get you the password and the site. So what the heck is going on here? What's up, dude? What's up, dude? You obviously know quality and respect. You better go after it.
once it gets real tough.
Oh, look at that. Don't even bother me. Don't even bother me. How's it going?
Did you look at them?
Yeah, I did. Yeah.
All right. I know. You do that one.
Okay.
I'm sorry.
Okay, I got it. I'll save the chicken talk for after we get going here. So please go ahead and work on that. We got a few minutes. Today's lab will be relatively straightforward. The issue is going to be if you've never used a function generator before, it'll give you opportunity to sort of look at some different types of electronics. And the cool thing about capacitors is that they're natural differentiators. So we can look at physical data where a physical property that's changing with time will literally produce a derivative response with respect to time. So it's truly calculus in direct observation, which is the reason I put it in here. So go ahead and, well, look over the lab if need be, but get going on that. Give me an email and I will respond. I need to get you the password and all that, and I'll just get it right to the team lead. I just don't want multiple people filling it out for the same group because then I can't figure out, I can't sort information very well. Okay? And so you have to figure out who's going to be in your groups. The more groups, the longer the presentation time on Friday. That's all final week. So there's always the little logistical issues, which is why I want to kind of balance things out.
You need to come up with a silly team name. Note, although not confirmed, it has been rumored by various sources that 90% of the project grade will be based on the team name and logo.
Is this your first one?
It's a joke, but still think we should play along. Come up with something good. Some chicken tenders or something.
To me,
Whatever you find.
One of them was about.
It's a joke.
Okay, so how do you want to do that?
Maybe that's why. Yeah, that's why. I'm like, yeah, that's what
What paper are you going to?
The one I just said. Fair number.
Is chicken a nugget used to being inside?
Well, yeah, he's an indoor chicken.
Yeah, that makes sense.
This many people.
like, I guess he likes it. It's a selection.
I don't know. I might take a million from
He's got some crazy feet.
So, I mean,
He's got those spurs.
It's all
like a
fire.
chicken.
yeah,
Looks like a
just
flip.
send it in, but I can do it.
How old is he?
You gotta log on then.
Whoa.
You gotta email us? Okay. And, he'll give you like a password or something like that. If you're in the email, send out an email at Platinum, and he'll send you a password as soon as, you email him.
You only get this at Cascade campus, right? You will never have a diaper-laden chicken in your physics lab in any other physics class.
Well, not with that attitude.
Unless you're taking your class in Nebraska. Then I think it's all bets are off. This is the latest physics student looking at. You know you, doesn't he?
He's met me.
So, go, man. Go. I don't know which one you prefer to be.
Yeah, I was just kind of reading.
Pick him up. Are you okay?
But this one doesn't seem bad. The fact that we're
Look at that. Look at that.
When you think
This class is done. That's what I'm talking about. I'm gonna eat on my watch, dude.
That's good,
Oh, look at that. There you go. There you go. There. I'm not gonna let you go. Relax. Okay, yeah. Then check out his Facebook. I hope nobody has a chicken allergy in here. Then I'm something going to anaphylactic shock and all that. Explain why there was a chicken in the class.
Whose chicken is this? This is school's chicken?
This is Q's chicken. No,
That's
this is,
chicken.
yeah.
That's what's up.
Like, I'm just about convinced I need one.
You eat chicken?
Yeah.
I get you chicken.
I want the egg, so I'm thinking more hen, but I just fall in love with this rooster though. It's awesome. You see walking him down the street, walking the rooster.
Yeah, and once he gets too comfortable. Right now he's nervous, so he's not trying to handle it.
Watch your step there. There is a logger program.
Is he gonna sit on the, that would be awesome if he sat right on the keyboard. Oh, look at that, he's perched!
It's about 5 years.
Oh no, he's just walking over.
He's trying to roost, but he doesn't really like this. Too much more friction.
Sent you an email.
You did? Okay, as soon as the computer comes on, yeah.
They only have 3.
In fact, I'll tell you what, I'm gonna run upstairs right
He's
now
had the extra
and get the emails out. Because
one.
you're gonna need that quickly
5 toes.
if you're gonna compete with papers.
Of course, of course. Of course. Check their,
Well, that says go with
yeah, I don't really want to do it right.
Got to get those popcorn.
I didn't look at somebody.
We got 3 minutes just for something.
You probably a wave particle.
That's not too much of
What do you guys? Yeah? You sound like you. That one.
What is that? Which one was it, Dave? I think you remember. Chain reaction one, that's right.
I was able to recall the name of the paper.
You're the team leader. That's classic management right there. They don't know what they're talking about.
Talk to my,
Are we supposed to start?
A lot of people are talking to you.
Yeah, right. One of the key skills of management is learning what are they called, like bonsai schemes?
Yeah.
Basic principle behind it is, someone asks you a favor, and you say, I'll take it. So you go and ask someone else a favor to do it for you, and in return, you do a favor. When it's time to redeem that favor, you ask the original person.
Bam.
And that's how you get a lot of things done without actually doing it.
It seriously is.
It's a legitimate management technique.
But I have,
people have to.
where I work, I happen to be kind of the last guy on the chain, so I'm usually the one doing.
Getting all the favors.
Yeah.
Doing everyone's favors.
Yeah.
Yeah, getting back to my desk yesterday.
And the best part about that is it ends up looking like you are doing all these things for all these people.
Really, you have to put your finger on it.
Or you can,
Sorry, I
you
probably.
can put your tongue on it.
You put your
Or you have a program written to do it for you. That's the best part.
That sounds like a steam generator.
Yeah, seriously.
I don't even know what chapter this is. 25.
Holy shit.
Yeah, that's what what's the actual question?
Was he asking what IMAX is for B and C? Yeah.
Don't say that. Don't go there.
How do you guys know what that's?
But then the second part of B,
Wow.
the maximum rate.
Really wants us to
Could either be really good or
Really bad.
decide who's doing what.
Some things that I'm like,
Like right here, right?
Do you guys want a fourth team member?
We can have 4.
Oh, no, he said he
Sure.
I misheard.
Do we have to fill up right now?
Yeah.
Why is that?
Otherwise, somebody has to get our papers.
Oh.
Well,
one especially with the circle.
the chart. The one that you circle or one.
regardless of who's
Oh, yeah.
leader and all this stuff, I just pick names.
Oh, right.
So, basically, for what's gonna be done, it doesn't matter what you're doing.
That was in. It was, but it was a different question. Like, because the ring was charged in the test. Yeah.
Chapter.
So if I hear
Yes.
You know what, that is something. Yeah, I just heard voltage is the difference between
Wait, you mean you already claimed it 2 weeks ago?
Yeah.
Oh, you already emailed him.
Oh, I forgot that name.
what's your bell pepper?
Just ask him when he comes back.
He did, that's awesome.
Okay, so I've sent the emails out for those that have responded. Yeah, I had that weird dream last night. Yeah, I did. No joke, I had this dream I was snuggling with a chicken.
You're wrong, Colonel Sandy.
Really, I was struggling with the colonel.
Okay. Well, you allergic to chicken?
No, I used chicken. That was a joke. Coughed up chicken feathers.
Oh.
I couldn't keep a straight face. If I didn't just finish it off, then I wouldn't have been able to pull it off. My mom told me that.
Selfie with the chicken.
Those feathers?
Yeah, I came in to visit her once. She said, "Hey, guys, she had this dream of making chicken."
I named our team He doesn't like it.
Nice.
Turtle.
And that guy is mean.
Oh, they are protecting that hand.
So what, compared to that wrist, it's like twice the size.
Well, that's a Japanese circular form
That's a nice
of
physics paper. Fermi Kupo.
That's why I wanted to leave it up to you.
The actual lab.
Yes. Okay, so let's get started with the lab, and you get set up. We have time to deal with all the other stuff. One thing about filling out that sign-up survey, I'm going to go through by timestamp, and if inadvertently more than one group picks the same project, then I'm going to go by the end. I'm going to go by the first that picked it, and I'm going to resend you an email saying, go pick a different one. And by the way, Russ, when you went in, did it show the results at the end when you did the survey?
No.
Okay, it's supposed to show the results. I think I forgot to hit that. So you'll know what, after you enter the results, it'll show what the what papers have been picked, basically. So if you overdo it, or if you double up inadvertently, then you just have to go back and pick a different one.
Well, maybe it didn't show them because there weren't results before.
Well, you were the only result, so it should still show. Because I did a test of it to make sure.
Oh, okay. I didn't see a result.
No, okay.
But I wasn't paying too close of attention when it turned to the green screen that I've seen every time.
Okay, it shouldn't be green. It shouldn't be green. Okay, so basically the idea, if you look at a capacitor in all of its glory, it doesn't have to be a parallel plate capacitor. But if you look at a capacitor, and we'll think about this capacitor as having some sort of voltage across it, then as the voltage varies, the charge accumulating on the capacitor will vary also. And we started out last week by looking at this idea of, it's like theme music. The definition of a capacitor as the ratio of charge to electric potential difference, if you will, on across either side of the conducting plate. And I'll point out that if you have a changing voltage, you'll have a changing quantity of charge. It will always be proportional to that. Well, they'll be proportional to each other, maintaining the constant capacitance. Now, what's kind of interesting about this is another way of looking at this is to say then that the charge at any given time on the capacitor will be related to, I'll bring the voltage over to the other side, this constant times the voltage. And I'll make a note that C is the capacitance. And capacitance has myriad units, coulombs per volt, all these C's floating around everywhere. Or sometimes we call it the farad. Now, we used a charge sensor last week, but the thing to kind of remember about this is that identify some terms. Charge sensor notwithstanding, it's rare that we ever directly measure an electrical charge quantity. the two most direct quantities that we measure are voltage and electric current. And the idea is that if you take the time derivative of both of these, of both sides of this relationship, dq dt should be related to C, which is a constant, dV dt. And the rate of electric charge flow across any conductor or along any conduction pathway is what's referred to as the electric current, or charge per unit time that flows across any conduction pathway. So typically we use the letter I to indicate electric current. I have no idea why we use I. We've got I for unit vectors. We've got, always have stuff all over the place. But the idea then is if we just redefine dq dt as current, then we'll note that if what we can directly measure are voltage and charge flow or current, then essentially we have a simple differential relationship between charge movement and voltage. And so I'll indicate on here that the current will vary as a function of time as the voltage or the electrical potential across the two sides of the capacitor varies with time. So if you've had electric circuits or capacitive discharge properties in previous physics class in high school, you'll have seen probably something similar to this. But the cool thing is that this measured quantity is related to the time derivative of this quantity. So if we were to apply a time-varying voltage or electric potential across the two sides of the two ends of the capacitor, then the measured current response, which would be the charge that's either going to the rate of charge flowing into or out of the capacitor, but never across. So if you have positive charge on one side, you will have a corresponding negative charge on the other side, even though there's no direct current flowing because of the induced charge relationship or, between the two conductors. And the relationship between how the voltage changes with time and the current that's observed is directly proportional to this capacitor property, this capacitance property. And ultimately, that's what we're going to do, is measure the capacitance by applying a time-varying voltage and measuring the associated current response. Exactly. You could not be more correct.
All right, buddy.
It's my best class ever. Best class ever.
Now he's comfortable.
Okay, so
All right. Well,
so that's essentially the idea. Now, double check here what I got going on. I didn't lose much. Okay, so now, because we're not going to be focusing on the current at this particular point in the game, if you will, what we are going to do is, well, let's consider an example. So let's look at some time-varying voltage as a function of time. And the easiest thing is to pick something like sine, the sine function. Make life easy. So say we have a voltage that's varying as a function of time. So and this voltage is varying with a magnitude of some maximum value. As a sine function. And as a reminder, omega is the angular or phase frequency of the oscillation cycle. So, this is the phase frequency of the signal. If we were to observe the current as a function of time, we would expect the current to look like the derivative of this. So where this is steepest, we would expect the current to be a maximum. And where the voltage signal flattens out, zero slope, we would expect the current to be zero. So even though we're at the highest voltage, the regions where the voltage is moving the least, or in the slowest rate, those will be the regions where no current flows. So again, it's a beautiful differentiating physical quantity. So if we were to plot this thing, we would expect where the voltage is the smallest, we would have the highest current. I'm going to call this I max. Where the voltage is changing at the slowest degree, it ought to be zero. Where it's steepest in the downward direction, we would expect it to be maximally, but flowing in the opposite direction. Where it's moving the slowest again, or changing at the slowest rate, we would expect it to look something like this, and on and on and on. So we would expect this thing to look like a cosine function. Exactly. Like that. Since I is related to C ddt. Now, here's what we're going to focus on. During each upward movement of voltage, or going from one end up to the top, during each positive or upward change in the electrical signal, that will correspond to a positive time-varying electrical current. The area under this graph if we were to calculate it, we would look at integrating the current as a function of time, dt. That would be the area under this graph here, where I is defined as some function of time. This would correspond to the total charge during the storing process, or the charge that's flowing into the capacitor. If we look at regions where it's a downward trend, charge is going to flow out of the capacitor. And ultimately accumulate an opposite sign on the opposite plates of the capacitor. And over this region, from Vmax to minus Vmax, you accumulate negative charge across the capacitor. This total quantity of negative charge, again, is related to the area underneath the current time graph. So what we're going to do today is use the current time graphs associated with a time-varying voltage response to measure the charge accumulation across the capacitor.